Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems and want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm gonna jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, everybody, and welcome to Wednesday night math night on, wait for it, Valentine's Day. I know some people love Valentine's Day, some people hate Valentine's Day, and some people are just indifferent about Valentine's Day. So, my name is Amy Sink. I am one of the math specialists here at the Learning Liaisons, and I'm so excited to be here with you guys. Yes, I have a husband. Yes, we will celebrate Valentine's Day. No, it's not going to be tonight. He is a pilot, so he is flying right now. So that's why I was like, might as well do math night. And I am wearing my festive Valentine's Day XOXO shirt. My son had a shirt on today that said, kicks before chicks. We are huge shoe people thanks to his aunt and uncle. And so that's what he was wearing today. But all that said, I'm so excited to be here with you. Let me know in the comment box. I always like to do like a little get to know you because it makes it feel a little less like a screen. Let me know in the comment box, where are you from? What test are you prepping for? And do you love Valentine's Day or not? And do you have any plans for Valentine's Day? I don't mind it. I don't love it. I don't hate it. I don't mind it. I used to love it, and now I'm just kind of indifferent. But I feel like my husband and I celebrate love all the time, so it's not a big deal. So let me know in the comment box where you're from, what test are you prepping for, and do you have any plans tonight or this weekend for Valentine's Day? We'll probably go to dinner or something this weekend. And I am happy to be back. Last week, we were on a cruise celebrating my son's second birthday. And you are probably going to ask, was it a great cruise? It was. With the exception of we got stuck in the middle of the ocean. Like, we didn't get stuck, but the weather was so bad that we didn't get to go to the Bahamas. So we just circled the ocean. But being on a boat is super fun. And so we didn't have to worry about it because, being in the boat is better than being on land because you're on vacation and people are cooking for you and cleaning for you. So we are going to go through some problems tonight. Some of them are going to be pre-K, some of them are going to be 12th grade, and everything in between. If there is something that you want to see me go over, let me know in the comment box, and I will add it to my next week list. I always like to include this because these sessions are for you. They're not for me. I mean, I love doing them, but it's to help you out. So if there's topics that you're really struggling with, let me know in the comment box, and I'm happy to add them to my next week's session so that I can tailor our sessions to your needs. So without further ado, let's go ahead and take a look at our first problem. I think I'm going to stick with pink and red today for the colors. Normally I like to change it up, but I think I'm going to stick with pink and red so that, because it's the theme for the night. So let's look at the first problem. At a local store, a pair of jeans costs $72, a pair of shorts costs $54, and a shirt costs $38. If a customer purchased 2 pairs of jeans and 3 shirts for a total of $276.06, what percentage of tax did the customer pay? Ooh, this is an interesting one. This is a problem that is truly for about 5th grade through high school, really, because it involves a lot of different concepts. Hey, Marco, it's good to see you. You like to celebrate Valentine's Day with your family. I will say it was fun with the 2-year-old. He brought me a little card with his little handprint. It was super cute. All right, so I'm going to start, because this was a lot of words. I'm going to start with the question and kind of go backwards. So what percentage of tax did the customer pay? So was it a 6% tax? Was it a 6.5% tax? What is this? Was it a 7% tax? What percentage was it? So I need to figure out what they gave me. They told me that jeans cost $72, shorts cost $54, and a shirt costs $38. And then they tell you what they purchased. So they purchased 2 pairs of jeans and 3 shirts for a total of $276.06. So this right here is useless information. However, people are going to think that they have to use every single number that's in the problem, and that's not the case. So I'm going to figure out how much the customer paid just for the retail that they purchased. So they purchased 2 jeans plus 3 shirts. So 2 times 72 plus 3 times 38, and I'm going to get a total for that. So I'm going to use my handy dandy calculator. 144 plus 114 equals $258. Now you're thinking to yourself, wait a minute, that doesn't equal out to what they said the total is. You're right, it doesn't, because now we have to figure out the tax. So I have 258, and I have to do something for it to equal 276.06. So typically when we do tax and I'm trying to figure out the percentage of the tax, scratch that, rewind. If I'm trying to figure out the total, I multiply this number by the percentage of that tax to figure out how much tax I'm paying. So let's explore this. Let's explore dividing both sides by 258 and see what it gives us. So X is going to equal 276.06 divided by 258 equals 1.07. What does that even mean? That means that I paid for my retail, which is the one whole, plus 7% tax, which equals the 276.06. So I know my answer is C. Let's move on to the next problem. Hey, Tammy, can I do a problem on functions? Ooh, that's a loaded question. Yes, I can absolutely do a problem on functions. What do you want me to do with those functions? Do you want to like factor them? So I give you something like f of x equals x squared plus 7x minus 12 and you factor it? Do you want me to do something like find g of x plus f of x or g of f of x? Do you want me to graph them? What do you want me to do with those functions? And that'll help me better understand where you're going with that. But yes, I can absolutely do a problem on functions. Woo! Excuse me. All right, let's go on to problem number 2. Oh, this is a good one, y'all. Steve has a wooden box that he wants to fill with cubes that are 1/4 inch wide. The box is 4 inches wide, 1 foot long, and 3 inches tall. How many cubes can Steven fit inside the box? 12 cubes, 48 cubes, 144 cubes, or 9,216 cubes? So let's go ahead and explore what this problem is saying. So he has this wooden box. Let's go ahead and draw the wooden box. I'm always going to draw the best I can. Any problem that has anything to do with geometry, because it helps me to visualize what we're working with. So he has this wooden box and he wants to fill it up with 1/4 inch cubes. So that means he wants to fill it up with cubes that are 1/4 inch wide. And because they are cubes, we know all of the sides are the same size. The box is 4 inches wide, 1 foot long, and 3 inches tall. Now, does it matter if you labeled your box differently? And let's say you put the 4 here, you put the 1 foot here, and you put the 3 inches here. In this situation, it does not matter because they're all rectangles. If it was a triangular prism, it would matter because technically this distance right here is the height of the prism because it's the distance between the two bases. But because volume of a rectangular prism is length times width times height, it really doesn't matter what order you put them in. So I'm going to go with this one right here. So some people might say, I know how to do this. Volume equals length times width times height for a rectangular prism only. So I'm going to do 3 times 4 times 1 equals 12. Done. That is not the case for a lot of reasons. That is incorrect because we don't have the same units. So right now we're multiplying inches times feet. I need to convert that foot into inches. So instead of 1 foot, I actually have 12 inches because there's 12 inches in 1 foot. So you're like, got it, Amy. 3 times 4 times 12 is 144 cubes. Done. That's still not going to be right because the cubes are not 1 inch cubes. If the cubes were 1-inch cubes, then absolutely we would be looking at a rectangular prism that has 3 times 4 times 12, and we would be done. However, the prism is being filled with 1/4-inch cubes. So let's zoom in and take and analyze what that would look like. If I drew 1/4-inch cubes inside this box, I'm going to divide this box into inches. So this is 1 inch, 2 inch, 3 inch, 4 inch. And this is 1 inch, 2 inch, 3 inch. And I draw a 1/4-inch cube inside of here. One, 2, 3, 4. How many do I have here? There's 4 cubes in that 1 inch. And there's going to be 4 cubes in this 1 inch. And there's going to be 4 cubes in this 1 inch. So really, if I converted inches into cubes based on the cubes that I've been given, how many cubes would be down here? 4 times 4. So 16 cubes can fit on this end. How many cubes can fit here? 3 times 4. So 12 cubes. And how many cubes can fit over here? 12 times 4, which is 48 cubes. Are you following me? Now I can do length times width times height. 12 times 16 times 48 will tell me how many cubes I have. 12 times 16 times 48, 9,216. This right here is a perfect example of how they will take what you need to know and they make it into a more rigorous problem. So they said, hey, we know that you need to understand volume, but you also need to understand conversions and you also need to understand like fractions, right? And so this right here puts it all into one problem, and it's really a fair problem. It's just really complex and really rigorous. So don't get tripped up by it and don't let it confuse you. Just know you have the foundational skills to solve this problem. You just have to chunk it piece by piece by piece. All right, let's go ahead and look at problem number 3. Hey, Tammy, it's a function problem. Now, I don't know if this is exactly the kind of function problem you were looking for. However, it's a function problem. All right. If the function 4x minus 5y equals 15 was graphed on an xy coordinate plane, which point on the line would fall below the x-axis? -9, 2, -6, 3, -4, -5, or -3, -2. All right. So this says if the function blah, 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 and I lost some of you already. Now, this is not a K through 6 problem. This is not a pre-K through 3 problem. However, my GK people and on, you got to know it. So if this function was graphed, blah, 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 coordinate plane, blah, 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 I lost some of you. Don't get tricked by that. This is a linear equation. That's it. You have to be able to recognize if you need to understand functions, And I'm going to do a little side lesson over here. So this is like a side note. F of x equals x. F of x equals x squared. F of x equals x cubed. F of x equals the square root of x. This is going to be linear. This is going to be quadratic. This is going to be cubic. This is going to be the square root function. And I could list for days. Now, is this the only way a linear function is going to look? No. Is this the only way a quadratic is going to look? No. Is this the only way a cubic function is going to look? No. These are the parent functions. However, knowing what those look like is really going to help you when you see something like this. You know this is linear because your x has a power of 1 and so does your y. So nothing crazy is going to happen. So if I was to graph that on the xy coordinate plane, what am I going to do? How am I going to start that graph? And everybody needs to understand coordinate planes. So even if you don't have to know how to do functions and graphing linear functions, everybody has to do coordinate planes. So let's not pay attention just because of that. So I'm going to go do my tick marks. Okay. And now I'm going to look and see. This is in standard form. Standard form is useless, not helpful at all. Right? So I need to transform this into either slope-intercept or point-slope form. So I'm going to subtract 4x from both sides because when I transform that, I need the y to be by itself. So I have negative 5y equals negative 4x plus 15. I'm going to divide everything by negative 5. And I get y equals negative 4 divided by negative 5 is a positive 4 over 5. X, 15 divided by negative 5 is negative 3. Now I have something I can work with. So I'm going to graph my y-intercept, which is negative 3. So I'm going to go down 3. I'm going to rise 4, run 5. Rise 1, 2, 3, 4. Run 1, 2, 3, 4, 5. Which point on the line would fall below the x-axis? So when I look at these points, negative 9, positive 2. Negative 9, positive 2 is going to fall right here. Doesn't matter if that is it doesn't matter if that's even on the line, right? It's not below the x-axis. So if this is a problem that you're struggling with and you're struggling with figuring out how to graph it, just look at the points and figure out what quadrant they're in. Hey, elementary people, you got to know which quadrant points are in. So let's take a look at this. Negative 6, 3. Over negative 6, up 3. Those are not completely accurate because I'm just totally doing a really brief, like, is it even in the right quadrant? No, that doesn't work. Negative 4, negative 5. Negative 4, negative 5. That falls in that below the x-axis. Check. Negative 3, negative 2. That falls under below the x-axis. Check. So now I need to figure out which of those points falls below the x-axis and is on the line. Well, I could do one of two things. I could plug these points back in and solve. And now graphing it and doing all of this work actually just became useless. Let's go ahead and do that. So 4 times negative 4 minus 5 times negative 5 equals 15. 4 times negative 4 is negative 16. 5 times negative 5 is positive 25 equals 15. 25 minus 16 is 9. 9 does not equal 15. And I'm now realizing that this problem, I don't think I did correctly, but that's okay. This is how you would solve it if it were the case. So negative 4, negative 5 does not fall on this line. Negative 3, negative 2. 4 times negative 3 minus 5 times negative 2 equals 15. Negative 12 plus 10 equals 15. That is not true. So no answer. Obviously, you would never have a situation where there is no answer. However, I'm remembering that as I was solving this problem in my bed the other night and creating this problem, I made a mistake. So all of that said, I made a mistake. But that is how you would solve the problem, right? So actually, as I was doing this, I realized that all of this wasn't necessary. Once I figured out what was below the x-axis, I could just plug it in. And my iPad just died. Totally normal. Welcome to Learn It Live with Amy Sink. Or not Learn It Live. God, that was from when I did COVID. Welcome to Math Night with Learning Liaisons. I don't know why I just said that. All right, let's see. It's connecting. I don't know why my iPad likes to do that. It's so weird. All right. Let's go ahead and move on to the next problem. Oh, this is such a fun one. Okay, let me share my screen and then I will read it aloud. All righty. If g of x equals x plus 2 divided by x minus 4, what is the value of the inverse of g of 3? All right. This is a really fun problem. Okay. So when we look at this and we see inverse of g, this does not mean we are doing the negative of g. This means that we are doing the inverse, not the negative. This means inverse. So let's connect again. So the inverse is when we flip the x and the y and then solve for y. So when I do that, I can go ahead and figure out what the inverse of 3 is, but I have to find that inverse first. So I'm going to do, instead of y equals x plus 2 divided by x minus 4, I need to flip those y's and those x's. So now I have x equals y plus 2 divided by y minus 4. And now I need to solve for y. Or I can plug 3 in for x and then solve. It doesn't matter which order you do it in. But remember, this value is x, not y. So I'm going to do multiply both sides by y minus 4. So I have x times y minus 4 equals y plus 2. Then I'm going to distribute. So xy minus 4x equals y plus 2. And as I sat there and thought, I was thinking, because I'm thinking to myself, how am I going to get all of my y's together and all of my x's together, because I'm solving for y to be by itself. So here's what I'm going to do. Now I'm actually going to do a hard stop, and I'm going to solve this two different ways at this point. So I'm going to show you what I would do just because my brain is algebraic, but then I'm going to show you another way to do it. So I'm going to add 4x to both sides, because whatever you do to one side, you can do to another. So I have xy equals y plus 4x plus 2. I just like my x before my 2. It's a preference thing. Now I'm going to subtract y to both sides. I cannot do xy minus y equals x. These are variables, and so that means that I cannot add and subtract unlike terms. So I have xy minus y equals 4x plus 2. What now? Well, now both of my terms on the left have a y as a factor. So I can factor the y out. So I can do, and I'm going to move this over a little bit, I can do y parentheses x minus 1 equals 4x plus 2. Because by factoring the y out, I have an x left over and I have a negative 1 left over. Divide both sides by an x minus 1. I get y equals 4x plus 2 divided by x minus 1. Now I can plug in 3 for x. Y equals 4 times 3 plus 2 divided by 3 minus 1. 12 plus 2 is 14 divided by 2 equals 7. So the inverse of g of x at 3 equals 7. Now, after this point, I lost some of you, and I recognize that. So if you could get to this point, or even to this point, then at that point, you could have just plugged the 3 in. Let me show you how. So I'm going to take the 3 and plug it in for all of the x's. 3y minus 4 times 3 equals y plus 2. 3y minus 12 equals y plus 2. Starting to look a little bit easier and a little bit more familiar? Yeah. Add 12 to both sides. 3y equals y plus 14. Subtract y from both sides. Those are like terms because they're both just plain y's. So I have 2y equals 14. Divide both sides by 2. Y equals 7. Interesting how there's two different ways for us to solve it. Now, I'm just going to reveal problem 4b to you so that you can see the difference. Ready? If g of x equals x plus 2 divided by x minus 4, then what is the inverse function of g of x? So in this situation, I could totally solve it with fewer steps, because once I found that inverse and started to convert it and then I got stuck, I could just plug that x value in my inverse into the function. However, this is the same problem, except they didn't ask what the inverse at 3 was. They asked what is the inverse function. And in that situation, I would have to do all of this. So I'm not going to resolve this entire thing for you because it's just not necessary. However, I wanted to show you that yes, answer choices are super helpful for something like this, but for something like this, they're really not all of that helpful because I'm going to have to find the inverse function. I can't just plug something in, right? So the difference between those two is important to recognize. Tammy, any function problem helps. More like f of x is 2x to the power of -3, and g of x is x minus 1. And then what am I doing with that? Am I adding them? And am I subtracting them? Am I doing f of x, f of g of x, g of f of x? Am I graphing them? Am I trying to find their intersection point? Again, there's a lot I can do with two functions like that. I'm thinking that you're wanting me to do something like this, but I could be wrong. So just let me know. All right, let's move on to the next problem. At a local high school, a rumor was started at 8 a.m. and 5 people knew about the rumor. Each hour that went by, the number of people who knew about the rumor doubled. How many people knew about the rumor at the end of the school day if the school day runs from 8 a.m. until 3 p.m.? All right, this is a fun problem too. So, theoretically, this problem wants us to use exponential functions. However, I'm not the biggest fan of just using a function that I don't carry in the top of my brain every single day. But for a problem like this, I can use a table of values because we're really not operating with a whole bunch of, it's not like we're operating with like 472 hours. Like how many people knew about the rumor 472 hours later? We're operating within a school day. So I'm going to create a table. Time, people. And then I'm just going to put time and people over here because I think I'm going to run out of room. So at 8 a.m., 5 people knew about the rumor. Each hour that went by, 1, 2, 3. The number of people who knew about the rumor doubled. How many people knew about the rumor at the end of the school day if we go from 8 a.m. until 3 p.m.? So we need to go all the way until 3 p.m. because that is the end of the school day. 2 p.m. is not the end of the school day. So it doubled. So times 2. 10. Doubled. 20. I'm going to use my calculator to move forward. So 20 times 2 is 40, 80, 160, 320, 640. So there's 2 approaches to this. The answer is 640. However, the first time I solved this problem, I will tell you that I got the answer. Give me 1 second. 1,275. Why? Because I added all of this up. However, it does not say each hour that went by, the number of people who knew about the rumor increased by a double amount. At 9 o'clock, the number of people who knew, the total number of people who knew went from 5 to 10. So 10 people knew about the rumor. And then from 9 to 10, it doubled the number of people who knew, not the number of people that are being added to the number of people that knew. Does that make sense? that creates two very different operations that we would do, because the answer is 640 because that's how many people knew about the rumor. I don't need to go back and add all of these numbers to 640 because that's not the number of people who are being added to the people who already know about the rumor. And that's a tricky thing to conceptualize and think about, but you have to read that problem really carefully. Now, again, could I have used exponential functions? Yes. Would I have used exponential functions if it was a lot more like doubling that was happening? Absolutely. But there was no need for me to try to sit and get frustrated with myself that I don't remember how to do an exponential function if I can just sit and double it in my calculator. Like literally, I sat here and went 5 times 10. No, sorry. 5 times 2. So 8 o'clock, 9 o'clock, 10 o'clock, 11 o'clock, 12 o'clock, 1 o'clock, 2 o'clock, 3 o'clock. Like all I did was hit the equal button over and over and over throughout the day. And I got my answer. All right, let's move on to the next problem. In the expansion of 2a plus 4b to the 7th power, which of the following are possible variable terms? And then you see them here. I'm going to give you a quick second to just look that over yourself, and then we'll solve it. All right. So I'm going to be really honest with you. I actually just learned this week. If I had seen this problem on my test, I'm going to be honest with you, I would have flagged it, moved on, come back to it, and done this. And some of you are going to be like, no! 2a plus 4b times 2a plus 4b. And I would have distributed it. So I would have gotten 4a squared plus 8ab plus 8ab equals 16ab plus 16b squared times 2a plus 4b. And I would have done that 7 times if I had the time to take the test, because I would have come back to it at the very end. I would have marked it and come back to it at the end. And if I had time, this is what I would have done, because I would have known no different. But I have a trick for you. In binomial expansion, which is what this is, binomial expansion, we can use Pascal's triangle, which tells us the rules of expanding a binomial. So this would be a binomial to the 2nd power, 3rd power, 4th power, and so on. And there's all sorts of rules that go behind it. But I don't even need to use binomial expansion to do this, because what I know is that the exponent here is going to match the degree of the exponents in the terms that are being used in the problem. So the first term is going to be something a to the 7th. And then the second term is going to be something a to the 6th, b to the 1st. And then the next term is going to be a to the 5th, b to the 2nd. And the exponents, or the degree of each of these monomials, is going to add up to 7. So when I look at this, 1 is not going to be a part of that binomial expansion. It's not going to be a term in the expansion, because 4 plus 2 is 6. That would be a term in the expansion of 2a plus whatever, 4b to the 6th power. But 4 plus 3 is 7. 7 plus 0 is 7, except this is not 0. That has a value of 1, b to the 1st power. So that actually has a sum of 8. 5 plus 2 is 7. 6 plus 2 is 8. 3 plus 4 is 7. So my answer is going to be 2, 4, and 6, which is C. Don't be like me. That is... Can you guys still hear me? I am like totally frozen on my computer. That is so weird. I have no idea if you can still hear me or not. Like it literally just, the entire screen froze and I don't know why. Bueller, Bueller, Bueller. Well, here's what we're going to do. If that was so weird. Like it literally like my computer just shut off for no reason. And then it just like turned back on. But then I had to like re-enter the stream, but then it was still streaming. That was so weird. Okay. Well, all I was saying was it has to add up to 7. That's it. So in this case, because the 7 is, thanks, Tammy. I was like, this is not okay. So all it has to do is add up to the variable degrees, or the variable exponents have to add up so that that monomial has a degree that the binomial has that you started with. All right. So I'm trying to reconnect my iPad because that whole thing was so weird. And now my iPad won't connect. So we're going to do the last problem upside down. Because, you know, why not? A 6-foot baby giraffe casts a shadow that is 10 feet long. The baby giraffe is standing next to an adult male giraffe that casts a shadow that is 28 feet long. How tall is the male giraffe? This right here, y'all, is just proportions. So all I'm going to do is I'm going to match items together. So I look at this and I say, what have they provided me? They gave me the height of the giraffe, and they gave me the baby giraffe's shadow, and they gave me the adult shadow, and they want me to find the height of the adult. So the way I think about this is I literally write this on my paper. Baby giraffe shadow equals adult giraffe shadow. Now, do you have to do it like that? No, you could do baby giraffe, baby shadow, adult shadow. It doesn't matter as long as you match the correct things. So I'm going to plug in my numbers. Baby giraffe is 6. Baby giraffe has a shadow of 10. Adult height, we don't know. That's what we're trying to find. Adult shadow is 28. Now, if this relationship was easy to see, then you could just, like, if this was a 20 right here, then I could just go like 10 times 2 is 20, 6 times 2 is 12. That's my answer. But this relationship is not easy to see, so I'm going to cross multiply to solve. I'm going to do 6 times 28 equals 10a. And so I'm going to use my calculator to do 6 times 28. $168 equals 10a. divide them both by 10. A equals 16.8, which is C. All righty. I have one more problem, but it's going to be dang near impossible to do upside down. So here's what we're going to do. I am going to turn it back over to Dr. A. We're going to end 3 minutes early because of Valentine's Day. That's what we'll say. It's because of Valentine's Day. It's not because of technology. Let me know in the comment box what else you want me to go over in the upcoming weeks. And I will add it to my next week list. And I will definitely go over more function problems. I think I'm going to do the g of f of x thing with the whole like f of x equals 2x, all of that. I'll attempt to create what I think you're trying to tell me. And if it's not, that's okay. And you can tell me, nope, try something else. And I hope that you have a wonderful week with your family and friends and whoever else that you're hanging out with this week. And I will see you next week. I am going to turn it back over to Dr. A. I'll hang out for a little bit to monitor the comments to see if there's any other requests for next week. And I will see you all next week. Have a wonderful week.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35. That will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well. And on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today. And hopefully we'll see you next week too. Talk to you soon.